I'm Anil Kumar sharing with you a question from the book Nelson, Advanced Functions. Now my students really need help with this as so many functions are involved in this particular question. It's really interesting and I hope all on the internet will also enjoy the solution and understand what really composition of functions is. The mass of a rocket just before launch is 30,000 kg. During its ascent, the rocket burns 100 kg of fuel every second and therefore decreases in mass at the rate of 100 kg per second. The mass m, acceleration a, and thrust t are related by the equation t minus 10m equals to ma. The velocity v is related to the mass by the equation m equals to 30,000 times 2.72 to the power of minus v minus gt. Determine the functions m of t, a of t, and v of t in terms of variable t and the constants capital T and g. Use the fact that a0 should be greater than 0 for the rocket to lift off to determine the constraint on t. So I'd like you to pause the video, understand the question, and then look for my solution. Well, let's begin by finding the relation for the mass. So it is given that the initial mass is 30,000 kg and during the ascent it burns fuel, decreasing the mass at the rate of 100 kg per second. Therefore, with respect to time, we can say mass, which starts with 30,000 kg, decreases at the rate of 100 kg per second. So that means minus 100 t. Right? So that is the equation for the mass itself. So we have related mass with respect to time. The mass m, acceleration a, and the thrust t are related with this equation. Let me write down this equation now, which is t minus 10m equals to ma. Now from this equation we can isolate a, right? So let's isolate a. So we get a equals to t minus 10m divided by m, or we could write this as t over m minus 10. Now m we know is 30,000 minus 100t. So in terms of time t, we can write a as t over 30,000 minus 100t, and we have minus 10. So that is the relation for acceleration, right? Now we are also given relation of mass with velocity. So now we will use that equation to find how velocity is related with time. So first we'll rearrange the equation. We have the equation as mass is equals to 30,000 and mass is given to us as this number, right? So instead of mass we'll write the expression for mass, which is 30,000 minus 100t, right? That is equals to 30,000 times 2.72 to the power of minus. Let me take minus common, so we get v plus gt. Now that is an exponential equation, right? So we'll take log later. Let's first divide by 30,000 and see what do we get here. So if I divide this by 30,000, I get 30,000 minus 100t divided by 30,000 equals to 2.72 to the power of minus v plus gt, right? So we took minus common, therefore it became plus. Now, so we can take log on both the sides, applying the logarithmic rules. So we'll get power will apply on this side, and here I'm writing this as 30,000 divided by 30,000 is 1 minus 100t divided by 30,000, right? So that is what I'm going to do, and I'll also take log. So we'll take log 30,000 divided by 30,000 is 1 minus 100 by 30,000 will be 200 zeros cancel, so we get 1 over or rather t over 300 equals to, on this side we get minus v plus gt times log of 2.72, correct? Now to isolate v, we'll divide by this log, right? And this minus, and then take away gt. So we can now write v, let me do it in two steps. So we'll do this as log of 1 minus t over 300, divided by log of 2.72, right, equals to minus of, okay, so let me take this minus here, so we'll write minus here, okay, minus, equals to v plus gt, right. So now we can isolate v, so we'll get v as equals to, let me write here, minus gt, right? So this, when you take on this side, becomes minus gt, and here we have minus of log 1 minus t over 300 divided by log of 2.72, right, minus gt. So we have velocity in terms of time, correct? So that is how they are related. Now, one more thing. So we have related all the relations. Let me highlight these relations. Okay, let's take a light color. So one, we got mass in terms of time, right? And then we got this acceleration in terms of time. So that's it. And here we got velocity, okay, in terms of time. Now one part of this is left, and that is determine the functions m of t, a of t, v of t in terms of variable t and the constant t and g. Use the fact that acceleration, initial acceleration, is greater than 0 for the rocket to lift off to determine the constraint on t. So we need to have acceleration as positive. Now acceleration is given here. For acceleration to be positive at t equals to 0, if I substitute t equals to 0, then what happens? So let me now work on this equation of acceleration. We'll use a different ink so that, and then I'll just push this page a bit forward. Now we want this expression to be greater than 0 when t is 0. So if t is 0, then I have t over 30,000, right? So 30,000 minus 10 is greater than 0, right? When t is 0, minus 100t will be 0. Now that implies, let me take plus 10 on this side and multiply by 300. So I get t is greater than 300,000, correct? So that becomes the constraint on t. So t should be greater than 300,000, right? So that is the value. Now units will be newtons for t tension, right? Now that is how it should be done. So I hope if you go slowly through this, you will understand how each and every function has been now related with respect to time. I hope that helps. Thank you and all the best.